select the area, okay, and you see it's a very nice mesh, right? You see the lines, the white lines, it is showing the mesh in the element, okay? And how many elements it has? How many elements are there? One element. How many elements are there? Number of one.
2500.
Umar, how many elements we have here? Okay, we have two choices now. 1 or 2500. There is a big difference. To whom you go? 1. Man. 1. Abdullah. I asked how many elements we have here. So one said not 1, 3 said 1,
It's
and
50 by
250.
it's 50 by 5.
by 5.
So these are,
I think it's one element with 250 mesh.
what is the difference between mesh and element?
Element we take like the type element is planar 1A2. This is the whole element,
No.
and this is the mesh we divided the element into.
I'm sorry, but this is the first time I listened this definition of element. Element is this. Okay,
The small
how you
one.
define the nodes here? Where are the nodes?
It's joining the
The node
elements.
is joining the.
This is the one element and it has 4 nodes, right? Okay. So physical model is one part, but we divided into 50 multiplied by 5, so it means it will be
250.
250
element.
elements, right?
But based on the Ansys, I think, when we select now the types, it just show me one type.
Yeah,
One
this is
element.
one type, but
One
we have,
element.
And Doctor,
for example, the bar elements, okay?
Okay.
How many elements we divided in one question? We divided in one element, we divided
Two
two
elements.
elements, and I gave you the assignment for 3, 4, 6 elements, right? The bar element is the one type of element, but here we have 5 bar elements.
and here
There is
Doctor,
one type of element, but here we have 250 elements, okay?
so this 1000 nodes here.
1000.
Nodes.
How you can calculate the number of nodes?
Multiply the element. Each element have 4 nodes.
No, but the element is.
Joining point, right?
Joining points.
So this is your second assignment. How you can calculate the number of nodes here? Okay. For bar element, if you have one element, how many nodes?
Two.
2 nodes. If you have 2 elements, how many nodes you have? 3. So nodes, element plus 1. Number of elements plus 1, right? Okay, but here I don't know. It's a square element. I need to see. Okay, so the mesh is clear.
So,
Yeah.
I didn't understand the first assignment.
Which one?
The map or
The assignment.
yes.
I have a model, a square plate with a hole of certain diameter, right? We have certain dimensions, and I need to discretize this model. Means I need to do meshing for this model, and I need to use map meshing.
Same
Okay.
this one.
Yeah, map meshing, right? Please remember the condition for map mesh. What is the condition?
Map,
Four side.
4 or
It
6.
should be 4-sided or 6-sided, right?
Only.
Only. If we have a triangle, and if you want to do the map mesh, the software will
cannot.
say no, you cannot do the map mesh here. Okay? If you have a circle, you cannot do it.
For us,
Sir?
we can't use the map for just
Truss. Truss actually it's a bar element, right? So for bar element we have 1D element, right? So this map mesh is for 2D elements or 3D elements. The concept of map mesh arises when you have 2D element or 3D element, right? For bar element it's a 9 element only.
Doctor, should we include the symmetry problem here? Or
I mean, I'm not asking you to solve this problem, just to discretize this problem. Okay.
Can we do it manually?
So,
Can I do it manually? Just because.
Yeah. I mean, I'm not asking in the
Uh-huh.
software, okay? You can do on the paper.
Okay.
Okay. You can do on your mobile phone as well, no problem. If you can do it. It's already 4, I mean, so we are running off the time. Anyway, let's go to the solution, the next step, right? And define loads, okay? Define loads means we are going to apply the boundary conditions or the loading conditions, okay? Apply structural displacement boundary conditions because the left hand side is the fixed, right? And we are defining on lines, right? Whenever we have 2D system, either we can define on the line or on nodes, okay? We don't have area actually. So on lines, select this line, the left hand side line, press OK, and this is the fixed support, right? So the first one is all DOF. It's a 2D physical problem, so we have maximum 3 degree of freedom, 2 displacements and 1 rotation. So you can fix all degree of freedom equals to 0. Okay. By the way, it's a numerical, because numerical method is very sensitive to the numbers, right? If you are writing if you are writing 0, and if you are writing 0.00000000001, it makes a difference, right? In analytical, they are same, in analytical, right? So I would always prefer to give the values. If you are giving the 0 value, I would always prefer to give 0.00001, for example, or let's say 0.000 something, or only 2 zeros or 1 0, right? So it will have some decimal places, right? So it will ease the computation. You can put the 0 as well, no problem. Okay. You can see we have 2 arrows. One is the upward side and one is this one. So the displacements and the rotations are fixed. Now, what we are going to apply? Force, right? On
the right.
Yeah, force on key points. Okay. What is the difference between on key points and on nodes?
Okay, points.
Yeah. How many key points we have in this model?
1.
4 key points, right? We define 4 key points. And how many nodes we have?
More than
250 plus 1, right? So 251. So it means at all the key points we have the nodes, but at all the nodes we don't have the key points. At all the key points we have the nodes. Okay? But at all nodes we don't have the key points. We have the nodes at extreme corners, right? And we have the key points, but in the middle we don't have. So if we are applying the load on the free end at the top, you can apply on the key point or you can apply on the node. But for example, if I ask you to apply the load in the middle, you cannot use this one because there is no key point in the middle, right? By the way, it's better to use on nodes.
On nodes.
So you choose this node, okay, Fy, right?
Yes.
And then what was the force magnitude in Newton? 10 kilonewton. So that is 10,000, right?
And the negative y there.
Yeah, negative, sorry. It should be negative. So minus will
Which node you choose
the free end, this one. Okay?
Doctor, at each method يعني should be save that data.
Yes, it's better.
So
After every step.
if I face the wrong and the 10,000 and I put in the positive y direction.
No, you can change it.
I can't change it.
Yeah, definitely you can change it. Go to the node, pick that node, it will give you the value, okay? Okay, save. So the loading and boundary conditions are done, right? Now we are able to solve this problem. There are many steps in between, but I'm skipping over. Current LS. LS stands for
Local.
local. Yeah. S. Local system.
Local system.
Okay. Any idea?
Local
Okay.
solution maybe.
This is load step. Okay, LS stands for load step. What does it mean? Load step. Just I'm giving you one example. If you have a bar, it is fixed at one end. For some time you are applying the bending load, let's say from 0 to 5 seconds. And then from 5 to 10 seconds you apply the torsion. So now in this case we have two load steps. One is the bending load and the other one is the
torsion.
torsion. But here we have only one load step, right? So just current ls, and it will give you some window. Press OK. Oh wow, solution is quite fine. Your laptop is very good. Anyway, it's solution is done, right? And now you can see the results, and this is called journal post processing, right? Post processing means to analyze the results. Okay. By the way, let me tell you one thing. Data and file options. Once you click that one, it will give you the file read result file, right? Once you click this one, this is the file, right? RST. This is the result file. .rst. R stands for result. Okay. So I want to see the result file, right? So go to the data and file options, because sometimes we have many results file, but I want to read one particular result file only. So this option is important. Data and file options. This one, read single result file. You can read multiple files as well. Click this one, and this is the working directory. So this is the file, right? But the important thing is here, you can see this is file, which is the name of the model, right? The model name was file, I think so. And .rst. R stands for result, ST stands for structure. So from the extension of the file, you can judge, okay, it's a structure analysis file, okay? For thermal, it is RTH, I think so, right? TH. For fluid, it is RFL. Okay, so you can choose this one, open, and okay, right? So it will read. Go to the plot results, contour plot, nodal solution. We have two types of solution, nodal and elemental solution. And in the next class, I will explain you the difference. Anyway, nodal solution and degree of solution. For example, I want to see the displacement in y direction, right? So click this one and press OK. So it is showing you the displacement, and you can see here. I'm sorry, this one we can increase, but you can see here we have red to blue, right? And this red is minus 0.22 10 to the power minus 1, and the positive one is minus 0.1, right? 0.195 10 to the power minus 1, or I don't know, but this is, anyway, this is the maximum displacement, this is the minimum displacement here, right? And you can plot the stress as well. So nodal solution, go to stress, and we have von Mises stress, right? Okay. So you can see this is the contour plot of stress. So you can see this is the maximum here, and then in this part we have the minimum. So the stress, maximum stress is 548 10 to the power 8. Oh my God. 548 10 to the power 8. This is point, or yeah, 0.548. I'm sorry, 0.548
Point, yes.
10 to the power 8. Could you please write this value? 0.548 10 raised to power 8, or another value 0.61. This is very close. 0.616 10 to the power 8. Okay.
Or you can say 54 megapascal.
Yeah. What is the unit of this stress?
Newton per meter.
Newton per meter square. The units are not coming. You have to remember yourself, because we use the dimensions of length in meter and the load in Newton. So this is Newton per meter square. Okay. So this is actually 54.8 megapascal.
But Dr. what is the red color here?
It's very small here. You can see this one.
And in the fixed, in the support.
Yeah, in the support actually. Yeah, this is the support.
But Dr. in the displacement, he make the blue one as a maximum.
Yes.
And then the stress, the red one is the
actually,
maximum.
then there was a negative sign. That's why.
Negative.
Okay. So this is the end of our. But for example, if you want to.
The stress is different in the left side.
Yeah.
From the top to the bottom.